So right now we're going to be talking about learning objective D. D has the words path, closed, cycle, and length represents to the length of a path. And the way that we're going to show what those definitions are is I have this very familiar graph up here, and we're going to talk about what the words path and cycle mean with reference to those. And now I do have to apologize, I only know like 12 letters, so I know a bunch of numbers, like at least countably many numbers, but only like 12 letters, so I gotta repeat them. Sorry. So the way I'm going to define path is I'm going to say, okay, here's the sequence of nodes, and the way I've written that sequence is U1, U2, and then I did a dot, 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 because there's like n many of them, and this represents a path so long as every time you go from any of the U, in this case I'm going to represent the index by t, going to ut plus 1, that is going to be part of the set of edges. Right? So for example, with this nice graph that we have here, I might say, oh, I don't know, T to W to U to V to R to S represents a path, right? And now there's something else that's kind of special about this particular path that I wrote, because I could have also said, I don't know, U, V, X, W, U, W, T. There's a big difference between the two of them. And the difference being, well, in that first path that I drew, it has no repeats. No repeats. Okay. And so when there are no repeats, that is what's called a simple path. All right, so a simple path is just a path that doesn't have any repeats in it. And the way that you might write that is any of these U's, let's say the index is now J, that Uj is not equal to Ui if J is not equal to I. All right, so no repeats is what it means to have a simple path. All right, so that talks about the definition of path, and it also talks about the definition of what a simple path is. All right, and so now we're going to talk about what it means to be a closed path. And a path might be closed if, let's say, U, V, X, W, and then you went back to U. Right? So this path is closed in that its end is the same thing as its beginning. But we can refer to this simple closed path with another name, which is cycle. Right? So it's simple in that only the first and end node are going to be the same, so there's really no repeats. As long as you call it a cycle, it's kind of implied that you're going to end up where you started in, and other than that, there's no repeats. So this is what's called a cycle. And a cycle is a closed, simple path. Final thing that you might want to talk about is what it means to have the length of a path. All right, so for example, with this cycle that I drew up here, you might want to know, well, how long is that cycle? And the way that we're going to do that is we're going to count the number of edges within the cycle. All right, and so the way that this is going to work is, okay, you go from U to V, V to X, X to W, and then W back to U, and you went around and you counted 4. All right, so this is an example of an even cycle because 4 is an even number. All right, in the example of a path, you don't have repeats, but you can still count the number of edges within that path. All right, so an example of that might be, let's say, XVRS. All right, so XVRS, that only has 3 edges. All right, whereas the cycle that we had up here has a length of 4. UVXW kind of looks like a square or maybe a rectangle. Another example of that would be, let's go back to my Facebook example. And let's add a new friend. Some bird. Cat and bird are friends with Star. And so as it turns out, Cat and bird and Star are all friends with one another. So in this learning objective, D, we talked about the definition of path, closed, simple, and cycle. A path is just a sequence of edges that connect a sequence of vertices. A path is closed if the first node is also the last. And it's simple if there are no repeated vertices. A cycle is a closed, simple path. In other words, only the first and last node are going to be the same.